Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing high weightage test 20 most incorrect questions done by the students. This test is based on differential equation variable separable method. Let's see the questions. The first question given is solution of this differential equation with initial condition y of pi by 2 equal to 0, then we have to find the value of function at pi by 3. Dear students, I think there is one error in this question. The error is that dy and dx are actually interchanged. Dy and dx are interchanged, they should be like this, then it will be done easily. Otherwise also you can do it, but this was meant to be done that way. Okay, the options are given that way only. So here if I write this way, I think it will become sin x into dx and you divide by 1 plus cos square x and then minus dy upon 1 plus y square equal to 0. Now you can see it is variable separable. All the functions of x are written with dx and all the function of y are written with dy. So integrate it, this and this, we will be getting this as tan inverse cos x with minus sign outside, because we will be taking cos x as t. So minus sin x dx will be dt. So dt upon 1 plus t square. For this integration, we will be putting cos x is equal to t. So minus sin x dx will be equal to dt. So this becomes minus dt upon 1 plus t square. So this is what I have done here tan inverse t. So tan inverse cos x. And here it is minus tan inverse y is equal to c, you can say, or tan inverse c also we write it sometimes. So at pi by 2, so when x is pi by 2, cos x will be 0, tan inverse 0 will be 0, and we are given y also 0, so c is coming out to be 0. So I think very simple question. We are getting this tan inverse y is equal to minus tan inverse cos x. So this y will be equal to minus cos x. We can write that way also, because tan inverse function is 1 1 function. It is a inverse function, so it has to be 1 1 and on 2. So y will be written as minus cos x. And they are asking the value of function at pi by 3. So cos pi by 3 is half. So function will be having value equal to minus half. So this question will have answer equal to A. I think simple question, very simple question, just simple variable separation and no other method I think for this question. Coming to this question, we are given a differentiable function fx with f dash 0 is equal to 2 and satisfying this functional equation. Now dear students, I would like to tell you how to solve this functional equation. First of all, by observation also we can say it will be some exponential function. I think we can always say that whenever x plus y, if you are giving to f and it is making a product of function f at x and at y, it has to be some exponential function, nothing else. And also f dash 0 is 2, the f dash x here will be equal to ax ln a. At 0 if you take, this will become 2 and that will be equal to I think ln a. So here we are getting a as e square. So this is one method of direct observation I will say, but I will tell you proper method, because they have given differentiable function, so we can do the differentiation directly of this considering x as a variable or maybe y as a variable, x as a constant. So if you differentiate it taking y as a variable and x as a constant, it will be fx into f dash y on the right hand side. Okay, because it is given differentiable and we are given for all x y. I think it is not mentioned, it should have been that x and y can be anything. So we can keep x constant, we can vary y. So this will be the result if you differentiate with respect to y. Now we have taken y as a variable, but now I will put y as 0. Okay, so this will become f dash x is equal to f dash 0, which is 2 into fx. Now considering fx as y, this will be dy upon dx is equal to 2y. We can integrate it after writing like this is equal to 2 dx. So we will be getting ln y is equal to 2x plus some constant. Okay, and from this functional equation, one more thing, very important thing, that if you put x equal to 0 equal to y, we will be getting f of 0 is equal to f of 0 square. From this we will be getting f of 0 equal to f of 0 square, which means f of 0 will be either 0 or f of 0 will be equal to 1. But if f of 0 is 0, then taking x as 0 for all value of y, this function will become 0 throughout. So f dash cannot be 2, because f dash 2 means it should be a variable function. It should be a function that is not constant actually. So we will be going with f0 is equal to 1. So if f0 is 1, we will put it here. So from that we will be getting y equal to 1. So this will be 0 log 1 at x is equal to 0 plus c. So the value of c is coming out to be 0. So we have properly proved it. That it will be y equal to e power 2x only. Nothing else is possible. So that is first part. If you are going with this functional equation, solving this functional equation properly, this is the method. Or you can do it by direct observation also. We must remember few of these results like x plus y, x into y, and few more. So this is coming directly from there also. Now the next part, the solution of differential equation dy upon dx is equal to fx. So we are looking for dy upon dx equal to e power 2x. I think very simple, variable separable, you can say dy upon dx equal to e power 2x into dx. So if we integrate it, it will be y equal to 1 upon 2 e power 2x plus c. And we are given f0 y of 0 for this equal to 1. So if you put x is equal to 0, that will be 1 is equal to 1 upon 2 plus c. So the value of c is coming out to be 1 upon 2. Okay. Now they are asking the value at x is equal to ln 2. So if I put x is equal to ln 2, it will be 1 upon 2 e power, it will be e power I think 2 ln 2 plus c, that is half. So this becomes 1 upon 2 into I think 4 plus 1 upon 2. So this should be I think 5 by 2. This was the question number. Yeah. So that is 2 plus half. So this is coming out to 5 by 2. So the answer of this question should be C. Answer of this question should be C. Okay. So there are two parts of this question. One, solving functional equation. If you do it properly, this is also one of the question of differential equation only, and then solving this given differential equation. Okay. Coming to this question, here we are given e power x into dy equal minus actually e power x into x square plus 1 plus 2x into dx. So everything is in terms of e power x, there is nothing, there is no function of y. So I will just take e power x this side or divide by e power x. We will be getting dy equal to, we can write also, so e power x will cancel it. So x square plus 1 plus 2x into e power minus x and dx. So this is what we are getting if we divide entire thing by e power x, and it is a variable separable. So just integrate it, it will give you y. Integration of it will be x cube upon 3 plus x, and the integration of this will be done by parts. Let me write this way, plus 2 into x, I will take this as a first function, e power minus x into dx. Okay, so this y is becoming equal to x cube upon 3 plus x plus first function as it is, integration of second function will be e power minus x with minus sign outside, then minus integration of differentiation of first function, that is 2, integration of second function, so e power minus x with minus sign dx. So finally we are getting this to be equal to x cube upon 3 plus x minus 2x into e power minus x, minus minus plus, one more minus sign will come because of the another integration. So minus 2 into e power minus x plus c is what we are getting for this question. So this is the solution, final solution you can say. Now we are given some initial value condition here. So let me use this space here after this. So at x x is equal to 0, they have given y as 2. So this will be 2, 0, 0, 0. Only this will be minus 2 here plus c, because at x is equal to 0 this will become 1. So c will be equal to 4. So c will be equal to 4, and they are asking the value at x is equal to 1. So put x is equal to 1, we will be getting 1 upon 3 plus 1 minus 2 upon e minus 2 upon e. So finally it will be minus 4 upon e plus c, that is 4. So 4 plus 1, 5, 5 into 3, 5 into 3 is 15 plus 1, 16 upon 3 minus 4 upon e. That is the answer of this question. 16 upon 3 minus 4 upon e. So A should be the answer of this question. I think not difficult. Some expression seems complicated, but not that much. Simple integration, but integration is involving 2-3 kind of integration. One direct integration, then integration by parts, and then I think standard thing, finding c and then finding the value at 1. Coming to this question, here we are given find the maximum value on the interval 0, ln2 for the solution of this differential equation. Given the initial condition as y0 is equal to 0. Now dear students, first of all you need to understand whatever solution you are going to get for every x and the corresponding y, this x minus y whole square will be positive. So it is going to be increasing function. If it is increasing function, so the maximum value will be coming at ln2. 0, ln2 is the interval, so maximum value will come at ln2. So to solve this question, I think this is not directly variable separable, it is actually reducible to variable separable, where we are given x minus y equal to dy upon dx. So the very standard thing is we put x minus y as t. So we will be putting x minus y as t. Now if we do this, its differentiation is 1 minus dy upon dx is equal to dt upon dx. Now this dt upon dx then becomes 1 minus dy upon dx, and dy upon dx in the question is given I think t square. You can see this x minus y is t, so t square. Now variable separable, dt upon 1 minus t square is equal to dx. Now dear student, you should remember the formula of 1 upon a square minus x square. Integration of 1 upon a square minus x square, although some of you may say that we can derive it in the exam itself because it is simple splitting into partial fraction. That is okay, but I will recommend you should remember it, because otherwise you will be taking time in deriving it. So 1 upon 2a, and I think it is a plus x upon a minus x plus c. Okay, so here it will become 1 upon 2 ln of 1 plus t upon 1 minus t with mod and equal to x plus c. Now we are given the initial condition y0 is equal to 0. So if you put x is equal to 0, y should be 0, and y should be 0 means this t will also be equal to 0. Please understand, if y0 is 0, so x, y both putting 0 will give you t also 0. So here this will also become 0. Let me write this condition that x is equal to 0, y is equal to 0, so t is also equal to 0. Now putting this here, it will just log 1 into 1 by 2 is equal to 0 plus c. So c is also 0. So what is the final thing that we are getting? We are getting ln of 1 plus t upon 1 minus t is equal to 2x. That's it. Okay. Now they're asking the maximum value. So I think we need to solve this function completely. So we will be getting okay. So we will be getting 1 minus t upon 1 plus t is equal to e power 2x. Let me see it from here. 1 plus t upon 1 minus t. Actually this was 1 plus here and 1 minus here. Okay, so and then t we can find using componendo and dividendo or by cross multiplication also. In componendo and dividendo, what we do, we will be subtracting numerator from denominator. So this will be 2t here, numerator minus denominator, and numerator plus denominator in the denominator. So that will be e power 2x minus 1 upon e power 2x plus 1. So this is t, which we took as x minus y, is equal to e power 2x minus 1 upon e power 2x plus 1. Now they are asking the maximum value. So as I told you in the beginning itself, the maximum value will be at x is equal to ln2. So put x is equal to ln2 minus y. It will be e power 2 into ln2, means it will be equal to 4. E power ln 4, so 4. So 4 minus 1, 3, and upon 5. So this gives you y equal to, I think, ln 2 minus 3 upon 5. Yeah, this answer is already revealed in this process, but I think this is the answer of this question. Good question, I will say. First, it is not directly based on variable separable. You have to do this method. And dear students, this is one standard thing that is taught in your classes, that first we teach you variable separable, then we teach you reducible to variable separable. So this is of that category only. And then maximum value they are asking, and it is hidden here that it will be increasing function. Some of you may think that I will first find y, okay, and then I will find dy upon dx and check whether maximum will come in between or at the end points. But I think this dy upon dx directly given is showing you, is telling you that don't do this dy upon dx after getting the solution. Just put the value at x is equal to ln2. Okay, so this question is done. Okay, in the solution actually they have done this thing, that they found y as a function, and then to find maximum value we check the derivative, and y dash we are getting like this. Okay, so they have proved it, this is positive. This can be done here itself, there is no need to do it. So the value of this function will be maximum at x is equal to ln2. Coming to this question, here we are asked the general solution of differential equation dy upon dx equal to ln dy upon dx equal to sine of x plus y. Again, this question is variable separable but not directly reducible to variable separable. Now in this question what we can do, we will be taking x plus y is equal to t, x plus y equal to t. So derivative of this will become 1 plus dy upon dx with respect to x is equal to dt upon dx. Now dy upon dx means it is sine t. So 1 plus sine t is equal to dt upon dx. So from this we are getting dt upon 1 plus sine t is equal to dx. Variable separable, we can integrate it directly. Now to integrate this 1 plus sine t in the denominator, there can be two methods. One method is my favorite method, I will say, that you multiply by 1 minus sine t in numerator and then denominator. So this will become cos square t dt is equal to dx. Okay, and then it is nothing but secant square t minus secant t tan t tan t tan t into dt is equal to dx. Now if you integrate it, the integration of secant square t is tan t and minus secant t, integration of this thing will be equal to x plus c. Okay, so the solution of this tan of x plus y, because t is x plus y, so tan of x plus y minus secant of x plus y is equal to x plus c. So answer of this question is B. Very simple question, I think, nothing difficult in it. I was talking about another method of integrating 1 upon sine t. So I'll tell you it here. But this method, if you do, you will not be able to match your answer directly. So if we are looking for integration of 1 upon sine t dt, we can write this as 1 plus cos of pi by 2 minus t and dt. Or maybe if you write it as plus, we will like to write this as minus here. Anything can be done, either pi by 2 minus t, then it will be plus, or you take pi by 2 plus t, then it will be minus. Then 1 minus cos t can be written as 2 sine square theta by 2. 1 minus cos theta is 2 sine square theta by 2. So we can write it like this, dt. Now this sine square going up will become cosecant square pi by 4 plus t by 2 divided by 2 dt. Okay, so this integration will become equal to, the integration of cosecant square is I think minus cot. So minus cot pi by 4 plus t by 2, and that's it, plus c. But here you can see it is not matching with this. To match with this, I think we may have to do the reverse calculation, because t is x plus y, so this will be x plus y by 2. So getting this in terms of x plus y will require maybe reverse calculation from here. Coming to this question, here we are given if y is equal to yx is the solution curve of differential equation x square minus 9 dy upon dx is equal to y square minus 4y with this initial condition and x greater than 3. If the slope of curve is never 0, okay, derivative slope is never 0, then we have to find the value of function at 7. Now in this question, first of all, it is directly variable separable. I can write this as dy upon y into y minus 4 is equal to dx upon x square minus 9. Now to integrate this, we will be breaking it into partial fractions. So it will be 1 upon y minus 4 minus 1 upon y dy. This also we can do it, or we have a direct formula also for that thing. Both can be done. I will write this as a factor 1 upon x minus 3 into x plus 3, and then splitting into partial fractions like this. For that you have to divide by 6 also outside. Okay, so the integration here will be ln of y minus 4 upon y. This will be 1 upon 6 ln of mod x minus 3 upon x plus 3 plus c. You can say 1 minute, I think I have made a mistake here. It should have been 1 upon 4 also here. Yeah, 1 upon 4 also here. So 1 upon 4, and I will like to write 1 upon 12 ln c here. Why 12? So that I will be multiplying by 12, so it will be 3 here, it will be 2 here. Calculation will be a bit easier. Now one thing, very important thing here, please listen carefully, that we are given x is greater than 3. So if I take x greater than 3, this will be positive. So I will keep this mod like this only, like x minus 3 upon x plus 3. There is no need to change it here. But when we are given one initial condition where f of y of 5 is 8 by 3, okay, so the value of y is 8 by 3. If I put 8 by 3 here, it is giving you negative. 8 by 3 minus 4 is negative, and 8 by 3 upon is positive, so total it is negative. So this will be written as ln of 4 minus, it will be written as 4 minus y, 4 minus y upon y, because mod, the job of mod is to make it positive, which will be positive if we take like this. And also I am multiplying the entire thing by 12, so it will be 3 here, and that is equal to 2 ln of x minus 3 upon x plus 3 plus ln c. So this is the solution of this differential equation. Now the value at x is equal to 5 is 8 by 3. So if I put it this, if I put it here, we will be getting 3 ln of 4 minus 8 by 3 means it will be 3 into 4, 12, 12 minus 8, I think 4, 4 upon 3, and here 8 upon 3. Okay, and that is equal to 2 into ln of, if we put x as 5, so 5 minus 3, 2, and 5 plus 3 is 8 plus ln c. Okay, so this becomes 3 into ln 1 by 2, or I can write minus 3 ln 2 because 1 upon 2, yeah, 1 upon 2. Here it is 1 upon 4, so I can write it as minus 4 ln 2 after 2 taken common plus ln c. So if you take this way, it will be ln c is equal to ln 2. ln c is equal to ln2. So the value of c is coming out to be 2 here. Okay, so we have found the value of c. Now the only thing that we need to do is to find the value at x is equal to 7. So what is my solution? I think this is my solution. Let me box it here. Just consider c as 2, nothing else is different from that, and we have to put x is equal to 7 and we will be able to get your y. So we will be getting from here 3 into ln of 4 minus y upon y is equal to 2 into ln. The value of x is 7, so 7 minus 3, 4, 4 upon 10, so 2 upon 5 I can write. 7 minus 3 is 4, 4 upon 10, so 2 upon 5 I can write, plus ln 2, because the value of c is 2, so ln 2. Okay, so this will become equal to, in single ln if I write, it will be 2 into 2, 4 upon 25 into 2. So this is what we are getting. So ln of 8 upon 25. Ln of 8 upon 25. So we are getting, let me take another slide. So this 4 minus y upon y will be equal to 4 minus y upon y. This 3 will go that side. So it will be 8 upon 25 power 1 upon 3. Let me check. This 3 will go that side, so 1 upon 3, and if you take it inside the log, so 8 upon 25 whole power 1 upon 3. Okay, so it should be, it should be 4 minus y upon y is equal to 8 upon 25 whole power 1 upon 3. Now we have to find the value of y. I can write this as 2, and we can write this as, I think 5 power, maybe option is also in terms of 25, so maybe I'll go with cube root of 25 here. Okay, now we can find y using component of dividendo. Your denominator is y, so keep your numerator as y. Okay, and in that case this cube root of 25 will come in the numerator. Dear all, whatever changes you are doing in the left hand side, same you have to do on the right hand side. You can think of that we have done the reciprocal, so y and this cube root of 25 has come in the numerator. And to get a constant in the denominator, what I'll do, I will subtract this from this. So it will become this minus this, so I think minus 4, not subtract actually, addition. So 4 it will be here. So adding means it will be 2 plus cube root of 25. So multiplying by 4 will give you the answer. So 4 into cube root of 25 upon 2 plus cube root of 25. So answer of this question will be A. Yeah, answer is A of this question. Calculation was bit tricky, not much, and also integration, that is also not much, I will say. Why I am saying not much? Because this kind of integration by partial fraction and this standard result, we have to remember it. And in the exam pressure, you should be so much, you should be so much comfortable with these calculations that you can do it there without error. In such kind of questions, there are chances of error. So please take care of that thing. If you are not very comfortable, I will say keep this question for the last. But make sure that you have at least 15 minutes for such question in the last, otherwise this will be skipped. Okay. Coming to this question, it says y is equal to fx be a function for x greater than 0 that satisfies this integration, and then we have to find f2. Now in such question, the first step would be integration. So we will be applying integration, that is done by Newton-Leibniz formula. So this is a function of t alone. So if you differentiate it, your upper limit will be differentiated, whose differentiation is 1, and then put t equal to x. So it will give you x square into fx minus differentiation of lower limit is 0, so nothing need to be written after that, plus differentiation of 5 is 0, equal to, this will be 4x cube into fx plus x power 4 into f dash x. Okay, now I'll write fx as y, so we are getting this thing if I bring it this side, so x square minus 4x cube into y is equal to x power 4 into dy upon dx. Now I think it is variable separable. just bring y that side and x this side, or maybe y this side we can write. So dy upon y will be equal to, I think, dx into x square minus 4x cube upon x power 4. Let me check once again. So it is kind of y gone that side, dy upon y, and dx will be coming here, so x square minus 4x cube upon x power 4. Yeah, that is perfectly fine. Now we just have to integrate it. But before that, one more step, I would like to simplify it. So dy upon y is equal to x square upon x power 4 is 1 upon x square minus 4 upon x dx. So the integration here is ln y is equal to minus 1 upon x minus 4 ln x plus some constant c. Now dear students, in such kind of questions we need to understand that initial value is given here itself. If you put x is equal to 1, both upper and lower limit will be equal, so the definite integration of this will be 0, whatever your function is, plus 5, and on the right hand side it is 1 into f1. So the value of function at 1 is just 5. So we will be using this thing to find the value of c. So put x is equal to 1, y equal to 5, so it will be ln of 5 is equal to minus 1 it will be minus 1 minus 4, we are putting x as 1, so this will be 0 only, yeah, plus c. So the value of c is coming out to be ln 5 plus 1, ln 5 plus 1, yeah, that should be correct. So c is coming out to be 1 plus ln 5, yeah, okay. Now they are asking f of 2. F of 2 means we will be putting x is equal to 2 here, so we will be getting ln of y is equal to minus 1 upon 2, and if you put x is equal to 2, so minus 4 ln 2 plus 1 plus ln 5. Okay, let me see the options. It should be like this only. So 1 minus half is 1 by 2 and plus ln of 5 upon 16. This is what we are getting. Okay, okay, fine. And then remove this ln from this. So we will be getting y is equal to 5 upon 16 into e power 1 upon 2. Multiplying this, after removing log, this will become e power 1 upon 2. So 5 upon 16 multiplied with e power 1 upon 2. So it looks like answer is C here. Answer of this question is C here. Yep. Okay. So that's it for this session. Thank you so much, students. Bye. Bacho, take care.